So we're going to look at part 1 of the New York State Geometry Common Core Review Guide that I created. And you can, if you are not one of my students right now, you can purchase it on Teachers Pay Teachers. And there'll be a series of videos that go through each of the parts and talk about which pages they go with. Now for part 1, we're going to focus on the first 3 topics. So this is going to get us from about page 3 to page 10. We'll talk a little bit about transformations and congruence with proofs, and we'll also talk about triangle congruence and triangle proofs. So moving on to page 3, you'll see on the top of page 3, there's actually a little typo that I'm going to fix right there. So it says a transformation, an isometry is a transformation that does not alter size and shape of the original image. So we're going to talk about, on this section, focus on translations, reflections, rotations, sometimes referred to as rigid motions. And we'll also talk about, sometimes you may run into questions where you have to say if it's congruent to a new shape, and you have to use those rigid motions to help you with that. So we're going to go through the rules, talk about reflections first, and we'll also talk about some of the misconceptions. So like first, for a reflection on the y-axis, what happens to the coordinate is the original coordinate, the x value, becomes the opposite sign of what it was. And for a reflection on the x-axis, kind of the opposite, the y value becomes the opposite of what it was. So for example, if I was going to take the point A, let's say I picked that point A was on -2, -3. That was the coordinate for point A. If I did a reflection over the x-axis like this, what I'd get would be A prime, and the rule says that x stays the same. So the x value is still going to be -2, but the y value is going to become the opposite. So in this case, it'd be -2, 3. So if I was doing a reflection on the x-axis, that's how it would change. So just because it says x doesn't mean it's going to change it positive. What it means, it's going to keep it the same as what it started with. So now, similar with that, if you take a look at the third one, reflection over the line y equals x, which would be the diagonal line, the xy become yx, so the numbers just switch order. And then with the rotation rules, we got rotation of 90, 180, and 270. And the rule to get from one to the next is you switch the order and change the sign to the first. So the first way for 90 degrees would be -yx. Then if you do the switch and change the sign of the first to that, you get -x, -y. And then if you switch the order and change the sign of that, you're going to put +y, -x. So if I took a point, let's say like C, which was -1, 4, and I want to do a rotation of 270 degrees, so I'm using this rule right here. C prime, my new point, my new image, I'm switching the order. That one stays the same, and then that one becomes the opposite. This C prime would be 4, 1. So we're going to kind of move on from there. Make sure you got those in, because you're going to use those with all the questions in this section. Now, we're going to look at question 3 on page 3, and it talks about, okay, which of these is a non-isometric transformation? Well, we just talked about before, reflections, translations, and rotations are isometric. So the only one that's not isometric would be a dilation. And dilation, in this case, the example would be C, because dilations are values that they multiply with the coordinate numbers. So think about that as you answer the questions on this side. If we go over to 4 and 5 and 6, we're going to look at one of the graph questions. So if you go to page 6 at the top, you're going to see a use of those rules. Now, the one we're going to look at right now, we're actually going to we'll look at C together. So C says, C is the point 0, 3. So we got it right here on the coordinate grid. And this, they say they want us to do a reflection over the line M. So you can see that they clearly marked line M here. And with reflections, if it's not an axis, what you want to do is you want to count the spaces to that line. So in this case, you're just going up 2 spaces. And then you want to go on the opposite that many spaces. So if you go up 2 more, you mark that point. That would be our new C prime. And that coordinate would be 0, 7. Now, similar, like we talked about before with rotations, if you look at the questions below it, same idea here. If you take like a point like 4, 6, which is this point right here, and it says we're doing a rotation, the rule is a rotation of 90 degrees for points A, B, and C. Well, that means that we're going to use the rule from the page before, which is negative yx. So we switch the order and change the sign of the first one. So the next point A prime would be negative 6, 4. And then just make sure, again, when you put the point in, that you label it correctly with the prime to say that, hey, it's different than the original one. So that is pretty much the gist of reflections, rotations, and translations as you're looking at it. Now we'll talk a little bit about page 8, which talks about congruence and proofs. And you'll notice we have a statement talks about 2 4-sided shapes. They could be a rectangle, could be a square, could be a parallelogram, maybe not. But because of this symbol, not only can we say they're congruent, but you'll notice that there are 4 different sets of sides that are congruent to each other, and 4 different sets of angles that are congruent to each other. And to determine that, you want to look at the name. The ordering in the name is the reason why these statements are congruent below. So if you take, like, for example, this statement, angle B is congruent to angle N. Well, here's B, second letter. Then you got N, also second letter. So those 2 angles at those points, if I was to draw those out, let's say I drew them out, I label them in the same order, A, B, C, D. And let's say I draw another one, I label it the same order, M, N, O, P. So I'm saying angle B will be congruent to angle N, which in this case, based on my drawings and based on the name, is correct. So make sure when you're doing these questions that you go ahead and pay attention closely to the name, because you don't necessarily need a picture if you have a statement saying that they're congruent to each other. So, now moving on to the last part, which is the third part of this assignment, or part 1. I go through some of the biggest things with proofs. We talk about writing down the given information. You want to make sure you label the pictures. So if you have the pictures and you write a statement, make sure you label them to go with it. We talk about the ways of doing a proof. And these 5 ways right here are going to be, based on the information, one of the ways we could prove them congruent. And then the last part, corresponding parts. If you are asked to prove, let's say, if the statement says prove an angle, let's say like angle A is congruent to angle D, well, that would be a corresponding part, or not the whole triangle, but you do have to prove the triangle's congruent first. So we're going to look at one of the proof questions, because I know that's the one that I had a lot of students struggle with. So we're going to start, and we'll look at question 13. So for this one, you start by writing your givens. So 13, BD bisects angle ABC, and BD bisects angle ADC. So now going from there, I noticed that it says this is bisecting angle ABC, so I'm going to mark angle ABC. And then bisect means cuts into 2 equal parts. So I'm looking at the 2 parts here, and I'm going to try to figure out individual names for those parts. So for my second statement, I'll write the individual names and say they're congruent. So we got angle ABD, is congruent to angle DBC. And then for a reason, angle bisector, because I have an angle being bisected. Now I have BD bisecting ADC, so I locate angle ADC, which is here. I'm going to mark them differently because they're two different angles. And then I'm going to come up with names for those two pieces. So I got ADB and angle BDC. And for this one, same reason. Angle bisector. You can use the same reason more than once. You just have to have the information and use the words that are there. You don't have to pull out of thin air in most cases. Now the other thing I want to point out is the way I named them. Notice that with the first one, B was the middle letter. So B refers to the location, the point where the angles are created. And same thing with 3. Now the last one, it's what I call the reflexive property, the shared side. We talked about that one a lot in class. So BD is congruent to itself. It's in both triangles. We have a reflexive property. Now I have 3 things marked, and I want to go through and say what they are. I have right here angle, side, and angle. So that's going to be my triangles, which in this case we'll call triangle ABD. And I want to make sure I label each triangle in the same order. So if I do ABD, that means the second one's going to be CBD. And for that reason, it'll be angle, side, angle. And then my proof statement is sides, which would be that side and that side. So for 6, I'd write that down. And then my reason would be the corresponding parts that we talked about a minute ago. So when you're writing these proofs, look for the words. So like if you look at the next one, midpoint, you'll see that word. Well, that means you're going to use that as one of your reasons. Okay. So keep that in mind as you are looking at proof questions. Okay. So that will kind of help you with the first 3 sections for this review guide. And if you need help with other pages, check out the other parts that will be on YouTube in the next day or 2.